Hello everybody, this is Suvarchala working as an associate professor in the Department of Computer Science and Engineering at Aeronautical Engineering College. In this video, I would like to discuss the strategy, greedy strategy to solve problems related to optimization basically. As we discussed in earlier videos, to design an algorithm, we need to know what are the existing tools are available to us, existing methodologies or strategies or techniques are available, so that for our application we can choose appropriate strategy, and also we will efficiently implement our application based upon the respective strategy complexities. So among various strategies, available strategies, divide and conquer, greedy technique, dynamic programming, branch and bound, and so on and so forth. Various designing strategies, algorithm design strategies are available, or techniques are available. Among them, we discussed already in the earlier videos about the divide and conquer concept, based upon which certain applications were also discussed, like quick sort, merge sort, Strenson's matrix multiplication, etc. Now we will move to the next technique, greedy technique. In case of divide and conquer, we didn't discuss about optimization concept all. We considered what may be the solution of the respective problem actually. So the greedy method is one of the techniques used to find optimal solution of any problem actually. In this video, we'll discuss what is the general strategy of the greedy method, the basic definitions related to this greedy method, and also one application problem we'll discuss based upon this greedy technique, that is job sequencing with the deadlines problem. Knapsack problem also based upon greedy method will be discussed most probably in the next video. Now, in this case, we are going to consider the algorithmic tools that are quite specialized. Algorithmic tools are available. We discussed about the divide and conquer. As I said earlier, divide and conquer, the problem is divided into sub-problems and so on and so forth. We already aware of that. Only to find the solution of the given problem. That's all. Whether the solution is a better solution or a best solution, we didn't consider at all actually. So there are some problems will be there. Various problems are there. Standard problems are there. They are intent to solve. They are not that much versatile actually. There are also more fundamental algorithmic tools are available, or strategies are available that can be applied wide variety of different data structures and algorithm design problems. Among them, we'll discuss now greedy technique. Related to greedy technique, we supposed to understand certain terminology. So greedy technique is based upon local optimal concept. Basically, it will find what are the feasible solutions are available. What is meant by feasible means has a solution which satisfies all problem constraints will be considered as a feasible solution. In case of, that means multiple solutions will be there for certain problems, but we have to choose the best solution. One of the best solution must be chosen by our algorithm actually. To do this process, this greedy technique, just it will see always what will be the best in at each step actually. That is the greedy part. Greedy part means it has to make the best local choice. It, of course, sometimes it may lead to the best global choice also, or a global solution also. But sometimes it may not also. We'll discuss all those things. Best local choice among all feasible choices available in that particular step. If this local choice results a global optimum, then the problem has optimal substructure. Otherwise, the problem may not have the optimal substructure. Once a choice is made in case of greedy technique, we are supposed to remember this most important concept. Once a choice is made, it cannot be undone. That means we cannot go backtrack. concept actually. So that means automatically once a choice is made, the choice if reflects subsequent solutions actually, or subsequent steps. So that's why once a choice is made, it cannot be undone on the subsequent steps of the algorithm. So even though if we are able to find out that choice which we have taken previously is not a good choice, because of that we may not get the optimal solution. For example, when we are going to consider as a playing a chess game. In case of chess game, once we have chosen a move, opponent will choose another move. This move cannot be revocable actually. So we have to look ahead. Without look ahead, we will, in case of choice also, we will assume that currently that is the best move which we are going to consider actually. That means fewest number of, sometimes what happens, number of coins, you would like to give some amount, and as far as possible fewest number of coins of change or coins, rupee notes of for a particular bill payment, etc. Then also some, always we will look into the local optimum generally. Now we will define what are the optimization problems. Optimization problem is a problem in which it's not just finding a solution, finding the best solution. So greedy algorithm works for optimization problems basically, and the difference between feasible solution and optimization solution is, feasible solution means a solution, any subset of the values that satisfies some constraints that can be considered as a feasible solution. That means we supposed to get the output or a result of that particular problem. Optimal solution means it is one of the feasible solutions that maximize or minimizes the objective function. What is an objective function? When we are solving certain problems, generally we will look forward whether to get the value or a maximum value or a minimum value. For example, if the problem is related to any a business, always we would look forward to get the maximization of the profit. Such a way we have to consider the solution steps. For example, when we are spending, let us assume that it may be while traveling on a vehicle, how much petrol or oil it will consume actually. In such cases, minimum consumption is we will consider. That is either maximization or minimization. Such type of problems are known as feasible, optimal problems actually. So most of in our real-time applications, up to certain extent, finding a solution is our major focus. But after that, our major focus will be getting an optimal solution. That means the best solution has to be found out. So various strategies are there to find the best solution, or optimal, or a maximization or a minimization solutions of specific or related problems. And one of the technique is going to be greedy technique. This greedy technique, how it works? This greedy technique works in phases. At each phase, it will consider what is the best option at that particular time. That's all. Without considering the future consequences. So, for example, from one node, 4-5 adjacency nodes are there. Among the adjacency nodes, whichever is the least cost adjacent node is it, that is going to be chosen. We won't consider from that particular node the reachability of the solution may be taking more time sometimes. That means always greedy algorithm focuses on local optimum, but not the global optimum. So we will choose local optimum at each step in case of greedy technique. Most of the time, it may end up with a global optimum. Sometimes it may not end up with a global optimum also. That is only the disadvantage of our greedy technique. Always, it will provide optimal solution. But the solution provided by the greedy technique need not be optimal always. Sometimes it better than that solution we able to find out. Remember these words, we will discuss these specific words when we would like to construct a spanning tree using greedy technique. So this greedy technique optimization problem involves searching through all existing configurations to find out the minimization or a maximization of the optimal objective function. This is a most straightforward technique. No need to worry. What is in the next step? Whichever is the best one, that is going to be chosen. Most of the problems have n inputs and require us to obtain a subset that satisfies the certain constraints. Any subset satisfying these constraints, as we earlier defined as a feasible solution, and any feasible solution which will give the best value, that will be optimization solution. So a greedy method solves a given optimization problem going through a sequence of feasible choices, and it starts from starting configuration will be given, and with best configuration it will start, then iteratively makes the decision that seems to be best from that particular current possible choices available. So that's why, as I stated earlier, the greedy approach does not always lead to an optimal solution. It all depends upon problems status actually. The problem that have greedy solutions are said to be possess the greedy choice property. That's why we will use the word greedy. Greedy means at that particular position, we will greedily select the best one, which may or may not lead to the optimum value or a best solution finally actually. So it is greedy approach is very frequently used in the context of the hard problems. Hard problems means the problems which are difficult to solve, in other words, you can say. In order to generate an approximate solution, because hard problems doesn't have any solution, so in order to generate approximate solutions for such problems, greedy approach is possible actually. Few optimization problems can be solved by using greedy method. Some of the examples we will discuss in the current video as well as coming 1 or 2 videos. Specifically, we'll discuss about a job sequencing scheduling problem, and we'll discuss one of the popular or a standard problem, a knapsack problem, and also we'll discuss how to generate a minimum cost spanning tree and shortest path problems. So these are all we are going to consider. The specific problems are going to be included in our or solved by using greedy technique. So greedy technique is going to be followed based upon these following steps. First, it will choose the first one, straightforward designing technique. The subset satisfies the constraint is called a feasible solution, and we will select the procedure itself based upon the some optimization measure, and several optimization measures are available for this particular problem actually. So here this is used to as a subset paradigm is going to be considered. This is one of the examples or a generalized method of greedy technique. We will call it as a control abstraction or a general method for greedy technique. Let us assume that this is a generalized approach. A is an array and n. First we will find the solution is null. No solution is there. For I 1 to n, we have to select one of the a's such that your x becomes optimal value. Based upon the objective function, one of the a will be selected. If the feasible solution, by adding this solution is going to be feasible or not, we will check. If it is feasible, then the solution, existing solution, whatever the choice we selected, that will be added. So this is the general procedure. So this procedure is going to be applied to all our applications further we are going to discuss. So that's why, for example, when you are having some solution status is there, it is already added. Let us assume that 1 is added. Then the best suitable value may be some x is there. X is going to be added provided 1 comma x is a solution to the problem. So that means first we have to check whether feasibility, then only this optimal value will be considered. So select is a method here we are using based upon given objective function, which is one of the values of a will be selected, input a will be selected, and it removes from the A and it adds to the solution based upon the constraint. So what is the constraint? We are checking if feasible. Feasible means it is a Boolean function. It will return true if by adding this value or a choice to the existing solution, it will give the optimal value actually. That means it is not violating any existing constraints. It will be checked. This process is continued until the selection of A is going to be got exhausted so that we can get the optimal solution actually. So some small examples, normal examples we will see first. And the problem is pick k numbers out of n numbers such that sum of these k numbers is the largest one. So first largest one, that means we have to calculate sum of the k numbers. For example, 10 elements are there. We have to select among them 5 elements such that the sum of the 5 elements is the largest sum. That means in normal situation, we have to first select the maximum, then next maximum, etc. But here it is not sorted order or not there. So for a while, I is equal to 1 to k elements we have to choose now. So that's why k times we are repeating the loop. Pick out of the largest one. So whichever is the largest that we are going to pick, then delete this number from the input and add to the solution. So this way we are going to consider. For example, if you have 15, 20, 30, 5 minus 6. How many totally? We have 5 elements are there. So first time I want to find out sum of the 3 elements which is giving maximum. First the largest will be selected, 30. 30 is added. This is removed. Remaining elements, 20 is the next one. This is added. 20. Next remaining elements, 50 is there. 15 is going to be added so that the maximum value will be considered as a sum of the largest number. One more example, shortest path I'll consider. So if a specific graph, find the shortest path from V0 to V3. Please observe that V0 to V3 when we are going to consider from V0 to V1, various edges are there. V1 to V2, various edges are there. V2 to V3, various edges are there. Okay, for example, let us assume that now this current example, V0 to V1 is 5, 1, 3 are there. Among them, I'll take shortest one, that is 1. And from V1 to again V2, various options are available. 2 is the shortest one, 2. From V2 to V3, shortest is 4, total 7. No problem, it's okay. For example, there is a path from V1 to V2. Let us assume that there is an edge from V1 to V2 having 2 as value. From V2 to V3 having 2 as a value. According to this greedy technique, I'll show why it is not providing optimum. According to this, when we are starting from V1, edges from the V1 are going to be 2, 5, 1, 3. Among them, 1 is last shortest one. So I'll consider 1, then we will reach V1, that is 1 plus. Okay, now from V1, the shortest value will be 2, 2 is added. So V2 reached. From V2, shortest path to V3 is 2, totally I'll get 5. Fine. But why is it optimum value? No. To reach from V0 to V3, if I'm going to directly go to V0 to V2, V2 to V, I'll get the value as a 2 plus 2, 4. So 5 is not optimal. Greedy technique we are applying, but it is not optimal value. Hope you understand the concept. It is choosing what is the minimum edge from that particular vertex. Whether from that particular vertex, whether we are getting the maximum or a minimum distance to the destination or not. That we are not considering in the greedy technique. So local choice. This is known as local choice. That means local optimum only we are considering. Because of this local optimum, getting a global optimum sometimes may not be possible. That's why greedy technique does not guarantee the optimal solution. In this example only just now I have shown you. So if any such type of currently it may not be optimum, but it may lead to the optimum further. So we will consider here, based upon this, the respective process is going to be greedy technique, optimization solution provides or not will be another example also we can see further. For example, one of the common example for greedy technique is counting the money. Counting the money here means, suppose we want to count out certain amount of money using the fewest possible bills and coins. Bills means you may consider it as a notes like that, coins. Greedy algorithm will be properly give some most of the time. At each step, take the largest possible denomination or a coin that does not overshoot means that does not exceed the original value which we would like to reach. For example, a dollar, $6.39 we have to give. $6.39 means first we will consider the dollars, then we will 0.39 we will consider afterwards. So amount 6 I have to pay. $10 may be there, but 10 is crossing 6 no, so that's why I have to check less than 6 first. So a $5 denomination will be considered, then $1. So this becomes 6. For 30.39 means 25 cents will be considered, then 10 cents will be considered, then 1 cent coins are going to be 4. So how many number of coins totally? 1 plus 1 plus 1 plus 1 plus 4. Totally 8 coins. So we need 8 coins to pay this amount of money. Okay. I'll take one more example. Similar concept. Let us assume that some fictional money system is there. Let us assume that it's maybe crowns or like that. Let us assume that it consists of 1 crown, 7 crown and 10 crowns only. 1 crown, 7 crowns and 10 crowns only. We have only these denominations, 1, 7 and 10. Using greedy technique, we have to pay or account how many crowns can be considered for paying 15 crowns. 15 crowns means maximum I have to consider. What is the maximum? 10 crown is there. So, 1 10 crown is going to be considered. After that 15, no 5. No 5 means what happens? 1 crowns are going to be 5. Totally how many? 6 coins. We have to use 6 coins we have to pay. What is our objective function in this example? Objective function is, as far as possible, minimum number of coins must be used by us. That is the objective function. So minimum means here 6 is used. But instead of that, if I can pay, for example, 15 means 2 numbers of 7 crowns and 1 number of 1 crown you are going to consider. Then totally how many? Only 3 coins are enough instead of having 7. 1 crown and 2 7 crowns are going to be considered. But greedy approach doesn't follow like that. First, current choice, the maximum crown coin value is 10. So that's why it will choose 10. It may not remember what happens next actually. For 5, there is no direct 5 denomination, only 1 denomination, 7 denomination. 7 is not at all possible. So that's why 5 is going to be considered as a 1 crown, 6 totally. But as I explained you, 7 crowns 2 and 1 crown 1, it will come to the 3 coins only. So the greedy algorithm results a solution, but not an optimal solution always. Sometimes it may give optimal solution is not going to be guaranteed also, in other words you can say. So that's why I have given 2 examples to you for the shortest distance by taking another example, and even coin denomination also we consider. So that's why if optimization is guaranteed optimization is required for us, then it is better go for another tool, another strategy or another technique other than this greedy. Of course, we'll discuss what are the advantages and disadvantages of greedy after completion of 2 to 3 applications actually. In the current video, I'm going to give one application, that is job sequencing with deadline. The problem statement of this problem is there are n jobs will be there and we have to process on a machine these jobs. Each job has a deadline and it will, when it is processed, a profit is going to be earned by that particular job. Let us assume that a job is I. It has a deadline greater than or equal to 0. Deadline means before our machine reaches that particular value, the job has to be completed actually. It has to be deadline and a profit PI greater than or equal to 0. So that's why we have to consider a job I has a deadline DI greater than or equal to 0. When it completes before that particular deadline, then it earns a profit of PI. Now PI is earned if and only if the job is completed by its deadline, and the job is completed means if it is processed on a machine before that machine reaches that deadline time. Each job will take only 1 unit of time. Please remember that only 1 unit of time is going to be processing time for each job, and only one machine is available for processing jobs. So these are all the constraints of our job sequencing problem actually. The job is completed if it is processed on a machine for unit of time. Only one machine is available for processing all jobs, and only one job is processed at a time on the machine. So I a little bit elaboratively, a feasible solution is a subset of jobs J such that each job is completed by its deadline. So various feasible solutions will be there, and optimal solution is a feasible solution with the maximum profit. So maximization here. So it is an optimum solution. Let us assume that without having any idea, just based upon the problem statement, let us assume that n is equal to 4. 4 jobs are there, P1, P2, P3, P4, and these are the profits earned by the respective jobs. Now, let us assume that the deadlines of the jobs are D1, D2, D3, D4 are 2, 1, 2, 1. That means the first job should complete by the time our machine reaches 2. Second job must complete by the time machine reaches 1 only. Third job should complete by the machine reaches 2. And fourth job is going to be completed by the machine reaches 1 only. Please observe that. So when initially machine starts, its time is 0. When it reaches 1 and when it reaches 2 means this is the timeline. By the time it reaches 1, what are the jobs must be completed? So deadlines of jobs, one is having D2 and D3. D2 and D3 are having values 1. Values 1 means by the time machine reaches 1, these must be completed. Can we complete both jobs? No. Only one of them is going to be completed by that time. Why? Because each will take 1 unit. If I am going to use any one of the jobs, D2, then after completion of D2, job 2, what happens? 1 reached. I cannot send D3 again. So that's why you please observe that the deadlines means machine deadline. By the time that machine reaches the deadline, before that itself our job must be get completed so that the respective profit is going to be earned. Otherwise, it's not possible. So in this, by the time we are going to, at the time of starting time, we can start either J, job 2 or job 4. And at 1 unit time, we can start either 1 or 3. Please observe, deadline means it is not the time taken by that particular job. It is the time before which it has to complete the job of the respective machine. So, suppose to complete by J2, J4 must be completed earlier, then J1 or J3 can be completed next. Only 2 jobs can be done by this problem. Others are not possible because deadlines are only 2. So, after 2, I cannot make any job to be entered in the machine at all. By that time, deadlines are completed actually. So, by considering the same example, P1, P2, P3, P4, these are the profits, 100, 10, 15, 7 these are the deadlines. So, first one, serial number, all possible solutions, brute force approach we will call it as a. Brute force approach means every combination will be checked by us. All combinations are checked. First one job I can consider. But one job when we are considering what happens, deadline 2 is also available, no? So minimum 2 jobs can be considered by us. So what are the combinations I can consider? So we can have D2 and D4. And I can have D1 and D4. D1 and D3. So D1 and D3. So D1, D4 and D1 and D3. That means combinations of these things can be considered by us. D1 with D2 with D1, D2, D4 and D1, D3. So D2, D1, D2, D3 or D4, D1 or D4, D3. Like that combinations can be. Of course, individual also can be done. But maximum allowed jobs are going to be only 2 in this example because the deadline is 2. Maximum deadline is 2. So 2 jobs are only possible. So what are the feasible solution? I'll consider all combinations 1, 2. What is 1? 1 is 100 and 2 is 10. Totally 110. But I cannot make one can. What is the deadline of 1? Deadline of 1 is 2. Deadline of 2 is 1. So that's why first 2 will be executed sequence. So first 2 will be submitted, then 1 will be submitted. Both are possible. 1, 2 is not possible order. Why? Because once 1 completed, the deadline 1 reached. So 2 cannot be reached further. So that's why 2, 1 is the sequence. 1, 3. 1, 3 jobs are going to be considered as a 100 plus 15, 115. And you can order maybe anything because 1 and 3 are having deadlines too. One of them can be completed before 2, no? So that's why 1 and 2, no problem. Order can be any order. 1, 4. 1, 4 means here 100 plus 27, 127. And what is the 1? Deadline of 1 is 2. 4 deadline is 1. So combination is order will be must be 4, 1. First 4 must be entered because its deadline is 1, no? It has to finish first before 1 itself. Like that, I'll get all other things. 2, 3. 2, 3 if you are going to consider. 2 is having profit of 10. 3 is having profit of 15. So 25 will be there. And order can be 2 is 1 and 3 is 2. So 2, 3 order is okay for us. Similarly, other combination, that means we are considering everything. 1, 2, 1, 3, 1, 4. 2, 1, 2, 2, 2, 3, 2, 4. 2, 1, 2, 2 is not considerable. So 2, 1 means 1, 2 already considered, no? So that can be considered. 1, 3, 1, 4. Similarly, 2, 1 is already considered. So 2, 3, 2, 4. And 3, 2, 4 is not possible. Why? Because 2 is having deadline 1, 4 is also having deadline 1. So both cannot be completed on same time. So only 2, 4 combination is not possible. So 2, 3 is possible. 2, 1 is not already considered. 2, 2 is not considerable thing. Same job is considered. So 2, 3 is possible. And 2, 4 is not allowed because both are having. 2, 4 is not allowed because both are having deadline 1. We cannot complete both in the same unit of time. Next, we have to consider 3, 3, 1. 3, 1 means 1, 3 completed. No, so 3, 1 is also same. 3, 2 actually. So 3, 2 means 2, 3 is over. No, so that can be considered. 3, 3 is okay, not possible. 3, 4. 3, 4 means here 4, 3 order is there. 3 is having profit of 15, 27. And 4 is having the profit of 27. Then combination will be 42. Now we will consider individual jobs. A profit of 10, 100, 15, 27 are there. What is the highest value we are getting? 127 profit is the highest maximum. So this is the optimal solution. That means 1, 4 jobs are going to be processed, but the order of processing will be 4, 1 is the optimal one. All these are feasible. So now hope understand the feasible solution. Feasible solution means possible solutions. These are all possible solutions. These are all possible solutions. As I told you, 2, 4. 2, 4 is not feasible. Why? Because 2 is having deadline 1, 4 is also having deadline 1. Both cannot be finished in a 1 unit of time. So this is not feasible. That means satisfying conditions. It's not satisfying the constraint. So all feasible solutions are there. Among them, the maximum possible value is 127. That is the optimal solution. This method is known as a brute force method actually. But remember, is it possible? Because here we are taking only 4 jobs and only deadlines are 2. Combination is okay for us. But in real-time application, multiple jobs and scheduling will be considered. So this is not possible. Now we will consider the greedy algorithm for applying, for getting optimized value, that is maximized profit of jobs to be executed in a particular order, in a different order, depending upon the order of the processing. So this is the procedure we will follow. Consider the jobs in non-decreasing order of the profits. That means we have to first sort our jobs in the non-decreasing order of the profit. When we are making this is the order, the respective deadlines are also going to be changed. Of course, in this example, previous example we consider it's the profit vector is already in the non-decreasing order. Then one by one you have to enter in, add it to the job. Job 1 is a feasible one. Then with 1 4 is feasible. 1 with processing sequence of 4 1. And 1 3 4 is not feasible. For example, 1 3 4 we are going to consider. So 1 3 4 is not feasible because the processing time of 4 third one is not possible in the given, because maximum deadline is 2 only, and 1 to 4 is also not feasible. 1 4 is an optimal here for it. That means what we are doing, we are selecting the maximum job first, that is 100. Then we are going to add next maximum 27. But while adding, we will check the deadlines. Okay, so maximum 27 means here fourth job. When we are arranging previously, what are the values are there previously? We are having 100, 10, 15, 27. Non-decreasing order means 100. First job must be 1. Next second, this one, second job is second. Next third job, next. That means 1, 2, 3, 4 we have to get. So job 1, job 2. So this is profits arranged. According to that, the respective P1, P4, P3, P2. Similarly, deadlines also D1, D4, D3, D2 must be arranged. Once you arranged, what happens here? When we are going to consider one by one, we will arrange first P1, P4. Okay, 1 is 2, 1 is 1. Order is changed, it's okay for us. Next, third one is added. P1, P4, P3. No, it's not possible. Why? Because third job cannot be added. Next, P1, P4, P2. It's also not possible since third job is not considered. Instead of previously, how many we selected? Totally almost 9 options we considered. But in this example, we consider only 4 only. Among the 4 itself, we are able to identify what is the largest one. So this is the algorithm we are going to follow. First, we are going to J is the set of the jobs completed, and D is the set of the deadlines of the job, and N is the number of jobs are available. When we are using this, first we will assume that all jobs are arranged, profits are arranged according to the order of the profit. Similarly, respective deadlines are also going to be arranged. Because if the deadlines are not changed, then the profit and deadline may not match the respective job actually. So we arranged here. Initially, we will consider a dummy job is added as a 0th one. From 1 to n we will consider, and we will check the respective job deadline is already greater than the deadline job of already included job deadline. Then only included, otherwise it may not be included actually. So this is the algorithm we are considering for I is equal to K2 or plus 1, and every time we will check job sequence is going to be added, whether because of the adding one position, then what happens, that will be considered here actually. We'll take one more numerical example. This is the optimal job sequence ordering of the following jobs of n is equal to 5. You observe here, jobs are already in order. 20, 15, 10, 5, 1. And D1, D2, D3, D4, D5, 2, 2, 1, 1, 1, 3, 3. Please maximum. What is the maximum delay? Maximum deadline is 3. Maximum deadline 3 means 3 jobs can be possible in our case currently. I'll consider one by one. So these are arranged. No, first I will include job 1, P20. Along with the job 1, job 2 can be included because what is the deadline here? 2. So 2 can be included, but the order can be P1, P2 or P2, P1. Both are possible in this example here. So P1, P2, P1 is going to be having 2. P2 is also having deadline 2, no? So that's why any order can be possible. This is the value 35. After that, the third job will be included. What is third job? 10 must be included. But 10, what is deadline of 10? 10 is 1, it cannot be included. P1, P2, P3 is not included. Why? Because not feasible. Because this is having 1. Other twos are even order changing also occurred also, because the respective jobs are having only maximum 2. 2 means only 2 jobs can be included. Next, we'll consider P1, P3 combination. P1, P3 means 30. Okay. Next, we'll consider P2, P3 combination, 25. P2, P3, P4 combination, order is going to be considered according to the P2, P3, P4. That means once job deadlines of 1 and 2 are completed, 3 only we will consider. Okay. So that's why when P1, P2 are going to be considered, the next job may be either P4 or P5. So whichever is having the highest profit, P4 is having highest profit. So P1, P2, P4 combination is okay, because D4 is 3 here. So third job can be pushed, third in the third position, D4 can be included actually. So that's why P1, P2, P4 means 20 plus 15 plus 5, 40. Order can be anything, because P1, P2 are 2 and P5 is, P4 is 3. So but P1, P2 can be earlier. P4 must be the last one. Job 4 must be the last one, because 3 is having it. Similarly, P1, P3, P4 and P3, P2, P4 combinations are available here. But what is the cost will be 3530. Among all these things, which job is having the highest one? We are having the profit, highest profit 40, if we are including the jobs, second, third and fourth jobs. Actually, 5 means multiple combinations will be there. But among them, we are reducing. First, we are including P1, then we are including P2, and next highest. Next, we tried for P3, which is not feasible for us. Then we try for inclusion of the either P4 or P5. But P5 is, job 5 is earning more profit, 5. So that's why we are considering this one actually. So 40 is the optimal solution. And the order of the jobs may be anything here, P2, P3, P4 or P3, P2, P4. But remember, P4 must be, that is job 4 must be having last job, because its deadline is 3 actually. So based upon these specifications, we can arrange them. One more example if we are going to consider here, because in the previous example already ordered, let us assume that job here n is equal to 7 is there, and the profits are 3, 5, 20, 18, etc. are there. I have to arrange profits in ascending order, no? Sorry, in descending order. First 30. 30 must be there. 30 is P7 and 20 next, that is P3, 18 P4, 6 is P6 and 5 is P2, 3 is P1 and P5 is 1. That means we arrange the jobs in the P, job 7, job 3, job 4, job 6, job 2, job 1 and job 5 according to their the profits. According to the deadlines are also must be changed. So that's why you please observe the green color. So P7 and D7 delay. D7 delay is 2 and deadline, sorry. D7 deadline is 2 and D3 deadline is 4. Like that we are including. When we are considering the highest profit, what is the deadline, maximum deadline we are having? 5. So fifth job can be arranged. Fifth job can be submitted as a, with D5 as a delay as a 5. So delays are various delays. 1 delay, 2 delay, 3 delay, 4 delay, 5 delays also. But in which order it has to be submitted, we will consider. Order is different, but the maximum profit is P30. So that's why 30 means P7. P7 means J7 must be added. What is the delay? 2. So it may be sent as a first job or a second job. We will see. Okay. Next, what is next profit? 20. So we are adding 30 plus 20. So when we are adding 30 plus 20 means what is the job here? 30 plus 20. What is the next job? J4. But delay is 4. So it can be sent as a fourth job also. No problem. That is the fourth one. What is the next profit? Next profit is 18. Job delay is 3. No problem. It can be sent as a third job. Next profit is 6. Set after 18, it is 6 and delay is 1. It has to send it as a first job only. Okay. So how many completed here? We will check. 1, but it is not feasible. 1 already, 1 be sent. and 5 is feasible with the job profit as a 1. That means we are including the jobs J7, J3, J4, J6, J7. Right? These are the jobs we included J7, J3, J4, J6 and the last job is J1. Profit 5 is J5. J5 is included. That means with the deadlines 1, 2, 3, 4, 5. So whichever deadline is having 1, that will be sent first. What is the deadline? Deadline 1 is for our D6. Deadline 1 is for our, let us assume that the profit is earned is 1, but the deadline 1 is for our D6 as well as D1. But we will send for the D6 only. Okay. So we will send the order in a order of first D6 means J6. Next after this deadline 2. Which one is deadline 2? Job 7. So after 6th job, job will be 7. Completed by second day. Next deadline 3. Which job is having deadline 3? 4th job. That is J4. Next deadline 4. Deadline 4 is having 3rd job J3. Next deadline 5. 5 is having here 5th job. We are going to consider it as a, please correct it, 5th job. 5th is going to be considerable change here. So here we are assuming the job processing. Here this is 5, D5. So we have to consider this is 5 and this is also 5. Okay, 1, 2, 3, 5. So these are going to be kept as it is here with optimal value 30 plus 20, 50 actually. We are going to have 3 plus 30 plus 18 plus 20 plus 1. The order will be in this order, but all jobs are included. So by using this greedy technique, what is greediness here? We are choosing the maximum profit related job in the beginning. Right? So we are having the maximum, next maximum, next maximum, next maximum, etc. You please observe here. When you are coming to the deadline job 6, deadline 1 is acceptable. When you are coming to the here, profit is 3 is there. But what is its deadline? 1, which cannot be added because with 1 already 6 was added. No, that's why. Then we are including profit, job 5, which is having profit as only 1. But even though we are including because its deadline is 5. This is greedily we are selecting. So that what happens sometimes we would like to discard the jobs because that they may not properly arranged according to the deadline, properly included according to the deadline also. The complexity of this algorithm is going to be quadratic complexity because we are using 2 for loops we are using. One for loop is number of jobs and second for loop is going to be included based upon the deadlines. Right? So K, we are going to K times the iteration takes order of K, where K is the number of existing jobs will be there. With the existing jobs, we have to add the new job and all jobs need to be considered n times. So it will be having nesting of the loops. It may be approximately big O of Sn, that is number of jobs multiplied by n, but it's not like that. Number of jobs included, in other words, you can say. So solution and up to that included. So that's why Sn means S is less than or equal to n always. So that's why the time complexity will be order of n square. If dA is equal to n minus I plus 1, then only the worst case only it happens. That is our delay is going to be, let us assume that all jobs are included. In other words, you can say all jobs are included. That means all jobs are included means if n jobs are there, our delay is going to be up to n. Then it will be considerable by us actually. The amount of space is required is to store delays as well as to store the profits of the respective jobs. So fixed amount of theta of S can be considered as the amount of space is required. It being a quadratic, it can be improvised. So how to improvise this algorithm actually? This algorithm can be improvised by using set union and find algorithms and using better method to determine the feasibility of the partial solution. The set union find, which we discussed already in the previous videos. So by using these two techniques, a little bit improvisation in the job scheduling algorithm can be considerable actually. If J is a feasible subset of jobs, we can determine the processing time for each of the jobs using the following rule actually. What is that particular rule? Sometimes if any job is not having any processing time, let us assume that. If there is no delay was specified, we have to assign a delay or a deadline or a processing time to that particular job in the slot alpha minus 1 comma alpha, where alpha is the largest integer r such that our r value lies between our 1 and delay of the ith job. The slot alpha minus 1 alpha is free, then only it is going to be allocated. So this rule, because of this rule, what happens? It delays the processing of the job I as much as possible without moving the existing jobs further actually. So that what happens? It can be improvised. It can be improvised. The algorithm can be improvised actually. That means the job has been assigned a processing time, not assigned a processing time. We have to assign in a particular slot so that what happens, which is already free slot can be allocated to us. If there is no such type of free slot, the new job is not going to be included actually. So for the faster, a little bit fastness of the algorithm can be considered or improvised by using this technique actually. Thank you for watching this video. I'll discuss about some other applications of this greedy algorithm in coming videos.
Like, share and subscribe. Hit the bell icon for more updates.